Okay, now we're going to be starting talking about rings and moons. Actually, this segment is to talk about moons primarily, and we'll talk about rings in the last segment. So all the Jovian planets have moons. As it says on the chart, the terrestrials have three. We have that real oddball, the one that we see in the night sky here on Earth very frequently, the moon. And then Mars has got a couple of little asteroids, we figure. And so basically we've got something going on. One of the big differences, though, between the terrestrials and Jovians is that there are no rings around the terrestrial planets. And in fact, the thought is that some of the moons in the Jovian planets may have rings. Rhea, one of the moons around Saturn. Here is a picture showing some of the moons and the planets in the Jovian system with other entities that can give you a size comparison. So Mercury is one of the smallest planets we got, and the moon is comparable in size to the four moons of Jupiter, the ones that we see with the some people can see with the naked eye. All right, there are large and medium moons, and here is a categorization of them. Saturn and Jupiter have roughly about 60 moons in total. As you can see, there are not that many really large moons. There are 4 around Jupiter, there's Titan around Saturn, and Triton around Neptune. All the other ones are kind of on the small side. Now, some of the interesting ones, as I spoke to before, is Rhea is an interesting one, and Enceladus is a very strange guy around Saturn. So we'll talk more about him later. One of the other interesting things that is going around Jupiter is if you go further out, what we have here is an ordering of the moons from and ordering dependent upon how far away they are from Jupiter. So imagine Jupiter over here, then the moon in closest orbit is Io, then Europa, then Ganymede, then Callisto. Now, the density of these planets decreases as they go farther and away from Jupiter, sort of reminiscent of the density that decreases as we go from the terrestrial planets to the Jovian ones. So there's some thought there that these moons were created from the rest of the nebula, in the region of Saturn. That's a possibility. The small moons, here is a picture of 6 of them, sort of potato-looking shaped ones, sort of reminiscent, if you will, of asteroids. And here we have Jupiter with its faint ring. Remember, all the Jovian planets have rings. They're typically not as bright as Saturn. In fact, all of them are dark rings. Here's a picture showing the large moons around Jupiter and a comparison of Earth's moon with them. So the Earth's moon is quite large and is very surprising for such a big beastie going around the Earth like it does. And one of the things I wanted to point out to you is one of my instructors was Stan Peele, and I was there, actually no I wasn't, no I was there when he made this prediction. A lot of people, and he predicted that Io would have volcanoes on it, and then he published this paper, and then not too much later it got verified by Voyager 1 as it went by it. And he basically used this idea of orbital resonances, and from the orbital resonance and the ellipticity of the orbit going around Jupiter, that Io should be an elliptical orbit and be squished and stretched. And we'll see that in a moment with this interactive thing here. Okay, so let's see, how do we get this thing started? Okay, so click on the image to see the title. All right, so we'll click on it. So here you can see it squishing, and we'll show the forces on this thing. And this is the tidal bulges that you see that have created the sort of strange shape that the moon has. It sort of sticks out towards the Earth. But the tidal bulges that we see of the oceans on the Earth having to do with the forces that the moon applies to the Earth. So you see, as we get further away, as Io gets further away from Jupiter, that the two forces get closer together in size, and so the moon circularizes. And then as it gets closer, it gets more football shaped. Okay, so now we'll come over here to this other one, and we'll see how the effect of the other moons. And these three moons are actually have orbital periods that are factors of each other. So here we have the orbital factors of each other, a ratio of 4 to 2 to 1, Io, Europa, and Ganymede here. Now, whenever these planets line up, either right next to each other or on the other side, then you're going to have these gravitational forces are going to be lined up and stronger in that direction. So not only is Jupiter squishing them, but also these moons are being squished by the effects of each other. So they are in, lockstep sync with each other. Okay, and that gives rise to the elliptical orbit, and this is from this information Stan Peele made his prediction, and that prediction was verified by the orbital flyby of Voyager. Okay, now because Io's surface is so squished and squashed, it's very volcanic. The core of this little moonlet is essentially liquefied, and then it seeps out to the surface because heat wants to go, energy wants to go from regions that are hot to regions that are cold, and so we end up getting these volcanoes of sulfur here. And the same sort of thing applies to Europa. If you look very carefully at some of these lines on here, this is an ice surface, and these are fault lines. And we'll see, look at this. This looks like, a fault system of the Hayward Fault and the San Andreas Fault, or the Garlock Fault. And notice right here, we have this fault line here, and it seems to have wanted to go up here, but then it got shifted over because of this fault. So one of the hopes is, by ESA and NASA, is will send a spacecraft out, and the spacecraft will drill through one of these fault systems and maybe find liquid water. So this is one of the possibilities of life outside of Earth that could be in the solar system. And so what we figure is going on in Europa is something like this. We have a metallic core, and we have a layer of other, stuff, perhaps rock, and then on the outside surface we have water that is liquefied because it is so warm. And the same sort of thing applies a little bit less to Ganymede. And Callisto is just a, classic ice ball out there, okay? Nothing much is going on out there. Okay, so we go to Saturn's moons. It's got even more moons than Jupiter does, and it has those fabulous rings. Titan is a very interesting critter. It was discovered by Huygens, and it's got an atmosphere. This is another possibility of life unlike we know it. It's got an atmosphere of nitrogen with some argon and methane and ethane in it. And if we look at the surface of it, as we do here, we see flow patterns and drainage channels, and we see these rocks. These rocks are made by water ice, and these flow channels are made by methane and ethane. So we'll take a look at this movie of the Huygens spacecraft, named after the guy that discovered Titan, closing in on Titan. So the atmosphere is pretty thick here. So the clarity is much to be desired until we get really, really close. But notice what we see here are things that look like mountains and valleys and water channels and lakes. It looks very reminiscent of what we would see here on Earth. Sorry, there was not much to say here. Just, this is just a pretty amazing video in its own regard. Now, as I was saying, methane and ethane seem to take the place of water here on the planet Earth. The idea being is water comes in three forms here on Earth: a solid, a liquid, and a gas. And we figure that methane and ethane are having the same characteristics on Titan. Basically, coming in a solid, liquid, and gaseous form. Okay. All right, Enceladus is that other one that's really bizarre, and we've got geysers coming out of this little moon. And you see, this is the standard picture we have of it. There's like no craters on this thing, and we know craters are a typical thing we see from the typical bombardment that we would get, and the only reason that craters disappear is if we have a resurfacing the planet. And these geysers create that resurfacing. Basically, we have liquid water coming out, and it is water. We have liquid water coming out of the interior of this moon. It shoots up into space, it turns into a solid, and then falls back onto the surface of the moon. Now, some of this material goes into orbit around around Saturn, and creates the white of the rings of Saturn. Now, after a while, the white gets denatured by the solar wind and turns a really kind of icky black. So that's why the other rings around the other Jovian planets are dark rather than light, and Saturn stands out for that reason. Okay, that's all we've got for this guy.